So in this segment, we are going to see the company database as an example. First, we are going to see a database schema design based on the simplified requirement for the company database. So as we said that we are going to assume that the database requirement is already in front of us. Okay, so we already have the database requirement. Now we are going to analyze this requirement and we are going to find out that how we can design a conceptual schema, means the ER diagram, from that requirement. So let's see first the people from this company has this requirement, and they are going to hire some database designer to design this conceptual schema. So this company database requirement, and it's a very simple version, could look like this. So one company, the company is organized into departments. Okay, so this company will have multiple departments. Each department has a name, number, and an employee who manages this department. Means each department has a means in a database we want to keep track of the department, where each department has name, number, and a department manager. Now we want to keep track of the start date of department manager, and one department may have several locations. Now each department controls number of project. All right, so each project has a unique name, unique number, and they will be located at a single location. Means for each project is located at a single location. Now database will also keep track of employee. Okay, so each employee has name, SSN will be unique for each employee, address, salary, sex, birth date. Each employee also works for one department. These are the requirement for each employee. Each employee works for only one department. See, every tiny detail are actually important for our database design. So each employee works for one department, but may work on several projects. Okay, we are going to keep track of the number of hours per week an employee currently works on each project. So we'll also want to also keep track of direct supervisor of each employee. Then an employee can have dependents. Now for each dependent, the database will keep track of their first name, sex, birth date, and their relationship to the employee, whether the dependent is child or spouse to the employee. All right, so the requirement, as I said, the requirement will be only in plain English word. All right, and this is just a very simpler version of your requirement. So what you want from your database, all right, which information you want to store in your database, all right, so that should be in the requirement. So now we are going to first see a couple of important concepts from ER model. All right, now in ER model, ER stands for entity. ER stands for entity relationship. Okay, E stands for entity and R stands for relationship. So in ER model, one important ingredients of ER model is entity. Okay, so what does entity means? Entity means a specific object or thing in the mini world that will be represented in the database. So in our mini world, for example, in our company mini world, we are talking about couple of department, employees, project. Okay, so they all are, we can visualize them like as an object or thing. So we want to represent them in our database. Okay, so these are our entities in the database. For example, like employee John Smith. Okay, so we have an employee John Smith, we have say department research, we have a project which is product X. These all are actually a object in our system, in our mini world. Okay, so there could be other person like say Mike. He is also an employee. So you can see that John Smith is an object of employee type. Mike is also an object of employee type. they both are entity of same type. So we can have multiple departments, research or product. So product is an object of department type, research is an object of department type, and product is an object of department type. So they are object of same entity type. Attribute is the properties used to describe the entity. So how do we describe employee? Okay, so we are going to have the idea how to describe each of the entity. We'll have the idea from our system requirement. That means how do we want to represent them. Say for example, if we look at the requirements, we will say that each department has name, number, employee who manages the department. Okay, and we also want to know the start date of the department manager. Means they are each of the attribute, they are going to define that entity. So attribute is simply the properties used to describe an entity. For example, for each employee, we want to have each employee will have their name, SSN, address, sex and birth date. So these all are the attributes of an employee. Okay. So each entity will have data values. A specific entity has a value for its attribute, right? So when we talk about John Smith is one entity of employee type. Okay. So John Smith will have like name John Smith, a specific SSN, specific address, and the specific value for each attribute. So these are the data values which will define a certain object. Okay, so each attribute has a value set associated with it. All right, and each attribute will have the value set, means a data type. What type of data type we are going to use to represent that value. So we are talking about entities and their attributes. So now if we talk about attribute, we are going to see how different type of attributes we can have. Attribute can be three type of attribute we are going to see. Okay, so first we are going to actually see that attribute can be of we can categorize attribute two types. Okay, let's see, we are going to see attribute can be categorized two types, simple and composite. Then we are going to see also attribute can be of like single valued or multi-valued, means attribute can be single valued or multi-valued. All right. Okay, so a simple attribute means sometimes also known as atomic. So a simple attribute means like that we cannot divide that attribute value. So each entity has only a single value and that value cannot be divisible. Okay, for example, like SSN. So one employee has an SSN and like the whole 9 digit. Okay, so 1 okay, so the whole 9 digit is part of the SSN, it cannot be divided anymore. Okay, so I cannot it cannot be divided anymore. I cannot say this is the first part, second part or third part. So it's not like that. So we are going to store as a attribute value like the whole 9 digit. So a simple attribute just a single value that cannot be divided anymore. Okay, we also say that it's a atomic value. Another example is like sex. So a person's sex can be either male or female. Okay, so they are example of simple attribute. A composite or compound attribute can be like, let's see, we are considering name. Okay, now if we consider name, a person's name can have actually multiple values. So it can have multiple other components: first name, middle name and last name. So altogether first name, middle name and last name will be known as a name. Okay, now let's see, we're thinking about address. So each address has apartment number, house number, street address, state, zip code, country, like that. Altogether they form a address. Okay, Now, depending on how we want to represent the attribute can be simple or composite. Okay, so if one attribute has multiple other components, this is known as a composite attribute. All right. Now, the composition may form a hierarchy where some components can just some components themselves can be composite. Okay, so let's see one example. Say in this composite attribute we have a second level of hierarchy. For example, we have a address has street address, city, state, zip. Now, street address itself is a composite attribute. Okay, so it has again in next level it has again number, street and apartment number. All right, but in one level hierarchy we can have the name. So we can think about name as a first name, middle init, and the last name. Now we can again categorize attribute as a single valued or multi-valued. A single valued means just one attribute has a only one value. Okay, but multi-valued attribute means that one attribute can have multiple values. All right. Say for example, now an employee can have only one name. Okay, so an employee has a name attribute which can be composite, but the value of the name will be each employee has only one name. Okay, but we're saying that let's say in one department can have multiple location. So if department location is an attribute, it can be like in multiple location. So like say Colorado, Texas, and Michigan. Okay, so this attribute can have multiple values, but this attribute can have only one value. So we can also categorize attribute as a single valued or multiple valued. Okay, so the composite and multi-valued attributes may be nested. Okay, so previous degrees of a student can be a composite attribute and multiple valued attribute. Okay, so like a previous degree, if I think about a previous degree of a student, one student can have multiple other degrees. So, okay, so multiple other degrees. Now each of the previous degree can be a like a composite attribute. Okay, so the previous degree is a multi-valued attribute, but the multi-valued attribute is a composite attribute. Okay, so one student has multiple previous degree, and previous degree is a composite attribute where each degree contains the information of college, year, degree, and field. Okay, so multiple previous degrees value can exist for a previous student. Now each previous degree has these four subcomponents, so that's why it's a composite attribute. If we have an entity with same basic attribute, they can be grouped together into the same entity type. So as I am saying that, let's see in your system you have John Smith, okay, and you have Frank. So John Smith is an object, or we can say here in entity relationship diagram we are going to say he is an entity. Frank is also an entity. Now they both are actually entity of same type employee. Okay, so entities with the same attributes can be grouped together into an entity type. Okay, so the type is we can say that the type of example of the type can be like employee or project. So each attribute of an entity type for we want to have an attribute for entity type. Okay, so for which we want that entity must have a unique value. So we have multiple entities of employee type. How we are going to uniquely identify each of the entity? So John Smith is entity of employee type, Frank is an entity of employee type. We can have multiple other entities of employee type. Now we need a special attribute by which we can identify each of the entity uniquely. Okay, so there should be an attribute. For that attribute, each entity must have a unique value. Okay, and that attribute we are going to use to uniquely identify each of the entity. For example, we said in our requirement that each employee will have an SSN and the SSN of employee must be unique. And we know that SSN of each different employee will be unique. Okay, so the SSN should be the unique attribute, or we can say that it should be the key attribute. So each project should have a number. All right, now each project should have a number, so the number could be an unique attribute. So key attribute or unique attribute, we are saying key attribute is the important concept of an attribute by which we are going to identify each of the entity uniquely. So the key attribute can be single or composite. Okay, so it can be single, it can be also composite. All right, say for example SSN. If employee has an SSN and SSN is the key attribute, it's an example of, I should say simple. So the key attribute can be simple or composite. Okay, now if I talk about the SSN of an employee, so it's an example of simple attribute. Okay, so it's an example of simple attribute. Simple attribute means I cannot further divide the value of the attribute. It's an example of undivisible or atomic attribute. But the key attribute can be also composite. Okay, say for example vehicle tag number. All right, now if I think about car, each car has a vehicle tag number, and that tag number or like license number. Okay, so this license number has actually two components. So it has the it has the state information and it has the license number. Okay, now I can say the license tag information, tag number. So this each car has a unique license tag number, but each license tag number has two information, state and the license number. Okay, now the state and the license number uniquely can identify each of the car uniquely. Okay, for example like TX 1046. Okay, now Colorado can have also 1046, but it's unique from that because the state is different. Okay, so there is an example. Let's say the car has the registration number which is unique. Okay, but the registration number is actually a composite attribute. Now an entity may have more than one key. All right, means we are saying that we can have we should have a key attribute by which we should be able to uniquely identify each of the entity. Now an entity type may have more than one key. For example, the car entity may have two keys. Okay, the vehicle tag number, which is the combination of state and license number, and we can have also a VIN. Each car has a VIN number. Okay, this VIN number is actually it is unique for each of the vehicle. Okay, now we are generally familiar with the vehicle tag number by which we can actually easily identify each of the vehicle, but the VIN is a large number. All right, which is unique number stamped on each new car, which is not easy to remember. All right, but still VIN is unique for each of the car. So each one entity, the one entity type can have more than one key. For example, like car can have more than one key. Car can have actually two keys. So for each license number is different for each car, and the VIN also different for each car. So in ER diagram, the entity type name is displayed in the rectangular box. So how do we represent an entity? We display them using a rectangular box. Okay, and the attributes are displayed as oval, for like that. Say for example, I have a entity of car. Okay, now car has couple of attributes, say model, make. So these are the attributes of car. Now the entity type name, we are going to show them using rectangular box, and the attributes we are going to show them using oval. So each attribute will be connected to its entity type. So there should be a connection by which we will look at the entity diagram and we will understand that this car has these couple of attributes. So if we have a composite attribute, okay, so components of each composite attribute are connected to the oval representing the composite attribute. For example, if we have a composite attribute like here, vehicle tag number, okay, which is the license plate number, sorry. So this one is a composite attribute. So as this is a composite attribute, we are going to show them using the oval. But this is a composite, so it has multiple components. Each of the components also we are going to show them using a oval symbol, the same symbol but like as another hierarchy. Say each of the vehicle tag has actually two components, the state, okay, and the license number. So you can see that car has a attribute vehicle tag number, but vehicle tag number is a composite attribute, so it has another two components. Okay, it's just showing all the attributes, but it is a composite attribute, so we are showing them as in another level of hierarchy. Okay, each of the key attribute will be underlined. Okay, so if it has a key attribute, for example VIN, so key attribute, each of the key attribute will be underlined. So I'm saying that vehicle tag number is a key attribute, I will underline that, and VIN is a key attribute, I will underline that. The multi-valued attribute will be displayed in a double oval. So if it has a multi-valued attribute means one attribute can have multiple values. For example, like department location. So one department can have multiple locations, so that means it can have multiple values. Okay, say Texas, Colorado, Michigan. So for each multi-valued attribute, we are going to show them using double oval. Now let's see an example. So we are saying that car, here car is an entity type. Okay, so car has couple of attributes. Vehicle ID is an attribute which is simple, okay, and single valued. So each of the oval here with a single line, they are actually simple attribute. Okay, simple attribute means single valued attribute. Now this one has double oval, means this is a multi-valued attribute. So a specific car means a specific car of entity type, means a specific car of car entity type can have actually multiple colors. Say for example this car 1, okay, this car 1 has two colors, red and black. This car has only one color, but double multi-valued means we allow to have one car multiple colors. Okay, now you can see that here registration is a composite attribute. Okay, registration is a composite attribute. Each registration has also state and number. Okay, combining state and number, it will combine, it will create one registration for the car. Now this car has actually two key attribute. Okay, so the registration for each car also unique, and the vehicle ID for each car also unique. Okay, that's why we are having underline for these two attribute. Okay, each entity type will have a collection of individual entities. All right, so for example, like in this example we are saying that we have three car of entity type car. Okay, so this list of values, this list of individual entities of same type will be called as an entity set. So here we have car entity type, and we have multiple entities for entity type car. So car 1, car 2, car 3, they will form a entity set. Okay, so the same name car, they will refer to as both entity type or entity set. We can say that this is the whole list is a set of car type, or we can say that the car is the entity type. Okay, and the entity set changes over time as entities are created and deleted. Okay, because entity set can change because we add a new entity like car 4, the entity set will change. Okay, and if we delete a existing car, this also is going to change the entity set. All right,